Hello everyone. In this video I want to look at the concept of a so-called limiting reagent. And what a limiting reagent is it means we mix two components of a chemical reaction in specific amounts. And the chemical reaction gives us the exact stoichiometric ratio in which they want to react. But in reality, we don't mix them in those exact ratios always. Sometimes we mix them and one of them or two of them or three of them or whatever are in excess, or what we call excess. And it means that one of them, there is too little to react with all of the other one, and hence it dictates how much of the products can actually form. Right. So that's what this example is all about. So the reaction we'll be looking at is the combustion of butane. And for this combustion reaction, we can assume that the only products are the gases CO2 and H2O. So let's go ahead and write the reaction. It's, of course, C4H10 combustion reaction means it just reacts with oxygen. It then forms CO2 gas plus water vapor. And you want to balance the carbons first, then the hydrogens, then the oxygens, and you'll notice I've done this in a previous video or another video, but you will notice that these numbers will help you balance your equation. All right, so now you know that's your chemical equation. And then we can start looking at these questions. What mass of CO2 can be produced by the reaction of so much butane and so much oxygen? So let's start by evaluating how much butane and how much oxygen we have. So we're given two masses, and we are not able to compare masses directly. We can only compare moles. So we can go ahead and calculate the number of moles of oxygen and the number of moles of butane. The number of moles of oxygen, of course, is equal to the mass of oxygen divided by the molar mass of oxygen, butane, mass of butane, divided by the molar mass of butane. This is 215.9 gram divided by 1.999 gram per mole, and this is 116.2 gram divided by 58.12 gram per mole. Okay, before I write down these numbers, let's quickly look at what the chemical equation tells us. The chemical equation tells us that 2 mole of butane will react with 3 mole of oxygen. Hence, 1 mole of butane will react with 6.5 mole of oxygen. Right, so that gives us an idea of what we at least need. So at least 1 mole of butane would need at least 6.5 mole of oxygen, or whatever. So we can start thinking about this depending on what numbers we get here. So we see we get 6.747 mole of oxygen. And we see we get 1.999 mole of butane. C4H10. Okay, so you can already start seeing from those two numbers, 1.99 is very close to 2. So it basically says we have 2 mole of butane. How many moles of oxygen would 2 mole of butane like to react with? Well, it would like to react with 13 mole of oxygen. Hence, The question is, do we have 13 mole of oxygen? No, we only have 6.7 mole. Right, so it means there's too little oxygen to react with all 2 mole of butane. Put differently, how much butane does 6.7 mole of oxygen react with? Well, probably only around about 1 mole. So it means if we're going to only use up 1 mole of butane, how many moles of butane do we have? We have about 2. So if only 1 mole reacts, is butane in excess? Yes, there's 2 mole of butane. So if only 1 mole is actually used up, it means there's some of it left behind. So let's put that into words. So it means 2 mole C4H10 must react with 13 mole of oxygen. Right? That's what our chemical equation. So you can write here, this is from the chemical equation. What is the situation that we have? We have 1.999 mole butane. The question is, how much must that must react with? How many moles? So with how many mole of oxygen should that react? Well, here is where you do your quick check. So you're going to write and say, you can do your ratios or you can just quickly calculate it. So the NO2 required in this case would be, we need 13 mole O2 for every 2 mole butane. We have 1.99 mole butane. And hence, that means we would require roughly 12.99 and so forth mole O2 is required to fully react or combust the 1.9 mole butane. Right, so the question is, 1.99 mole needs 12.99 mole oxygen. But how many moles of oxygen do we have? We only have 6.7. Hence, that means O2 is the limiting reagent. Right. And that means exactly what the word means. It's limiting the reaction to how much O2 there is. The reaction cannot produce more products than what there is O2 available to react. Okay, so that basically means, so in put into words, that implies O2 dictates the reaction amounts. Right. So now the question is, what was our question again? What mass of CO2 can be produced? So we know all the CO2 will be, or all the O2 will be used up. There will be some butane in excess, but we can produce, or we can determine how much CO2 is going to be produced from the O2. So we know the amount of CO2 is going to be ratioed. So you can do your 13 mole O2 to 8 mole CO2 stoichiometry, and you'll get to this equation. You want to get to mole CO2, so it's 8 mole CO2 forms if 13 mole O2 reacts. But how many O2 moles react? We only have 6.747 mole O2 actually reacting. Cancel the mole O2s, you will get 4.15 etc. mole CO2. Right, and then from that you can get the mass. The mass of CO2, then of course equal to the number of moles of CO2 multiplied by the molar mass of CO2. Molar mass of CO2 is 44.01 gram per mole. Gives you a rounded value of 182.7 gram CO2 that can be produced from this. And of course, yes, you're completely valid in saying there will be a certain amount of moles of butane left. You can calculate it yourself. There should be around about 58.1 gram of butane left. Around about 1 mole of butane will be left over, because that's a typical question. Right, and that's typical, like I say, because that's the next question. What mass of excess reagent is left after the reaction is complete? So we said the excess reagent is the butane. So the question here is, with how much butane did this O2 react? So what we relate now is 2 mole butane to 13 mole oxygen. Right, we want to determine the number of moles of butane that 6.7 mole of oxygen would have reacted with. So that gives us then the number of moles of butane is equal to 2 mole of butane reacts with 13 mole of oxygen, and we have 6.7 mole oxygen. It's going to give you roughly 1.038 mole butane. Right, and what is this? Reacted. So maybe just make a note for yourself, this is reacted. Then we need to calculate, well, therefore, the number of moles of C4H10 unreacted is equal to the original amount, which is 1.999 mole minus this 1.038 mole. It's going to give you a value of 0.961 mole butane, which is unreacted. Right, and from that we can get the mass. So therefore, the mass butane unreacted equal to the number of moles. Okay, so number of moles butane unreacted multiplied by the molar mass of butane. So I'm just going to write molar mass of butane is, of course, 58.12 gram per mole. So we plug in here 0.961 mole multiplied by 58.12 gram per mole. And you'll get, once you've rounded to 4 significant figures, 55.87 gram C4H10 unreacted. Right, I just checked my significant figures. 4, 1, 2, 3, 4, yes, so 116.2, 4 significant figures, 215.9, 4 significant figures, and that is it. Okay, so what's the important thing here? To determine limiting reagent, you can go either or. You can check, how much butane would have reacted with how much oxygen, or how much oxygen would have reacted with so much butane, and then you check if you get an answer that is larger, like for example, we got that nearly 13 mole is required to react with so much butane, and hence the number of moles of oxygen was too little, then we know oxygen is limiting. If we started with the number of moles of oxygen and determined with how much butane it would have reacted, and we would have then gotten that the number of moles of butane required is less than what we have available, so hence then we would have just made the conclusion butane is in excess and hence oxygen is the limiting reagent. And then from there on, you just need to keep the logic of what remains in excess. What does the word excess mean? It means it's unreacted. It just stays there. All right. Okay, thank you for watching, and I'll see you in the next video.